Okay, welcome back. I'm going to be doing trigonometry. This is going to be part 1 of a 2 or 3 part series. So we're going to be starting off mostly with radians and degrees and evaluating them or finding reference angles and graphing them. All of these are no calculator questions, so we're going to do them without calculators. So for the first question, I just want to find what the general idea of what it's going to look like is. You want to know what your reference points are. So for 90 degrees, you have 1.57 radians, 80 degrees or 180 degrees, 3.14 radians, 270 degrees is 4.71 radians, and your 360 degrees is 6.28 radians. So you just have to know this so that you know where about it's going to be. We already know that because it is less than 6.28, more than 4.71, it's in quadrant 3. But we can also show that by doing 4.71, and then what plus 4.71 is 5.77, and that is going to be 1.06. So we know that this is how far past our 270 degrees that our angle is going to go. So this is just to help you draw it. And then to find your reference angle, because it's in quadrant 3, we can just do 6.28, take away the 5.77 here, and it will give us what our reference angle is. So 6.28, take away 5.77, and that is going to be 0.51. So your reference angle is 0.51, and to confirm that, we just add it to here, and we should cut 1.57, which we do. So just because the angle between here and here is 1.57 radians. Anyways, so now we can actually go ahead and sketch that. So it's about 1 past our 4.71, which is about 57 degrees. So if you draw that kind of past 45, like so, it should look something like that. You just go around, and then this is your reference angle here. And that's how you do that question. Okay, next question is the same idea, but now we're going to be doing it for a negative angle. And we'll also have it in this form instead of just a whole number. So let's go ahead and do that. So we know that 2 pi is 360 degrees, but an easier way to do that is that you could just do pi. So pi is going to be 10 pi over 10. And we can see how many times that the 10 goes into 47. Because we can see that when we have 10 pi, it's going to be 180 degrees when we have it over 10. So it will go into 47 4 times. So we get our angle equals 4 pi. And then we're left, negative 4 pi, because I forgot we have a negative there. And then plus our negative, and we're left with 7 pi over 10, negative 7 pi over 10. Okay, and then we know for 90 degrees, I can actually just go ahead and write this here. Okay, so we know for 90 degrees we have pi over 2. We have pi for 180, 3 pi over 2 for 270, and then 2 pi for 360. And pi over 2 is the same thing as 5 pi over 10. And 5 pi over 10 goes into this one time. So we can have negative 4 pi plus negative pi over 2. And then we're going to be left with negative 2 pi over 10, which is the same as negative pi over 5. Okay. So this is just so we can draw everything. So we know that we're going to go around in the negative direction twice. And then we're going to go over negative 90 degrees. And then we're going to go over a negative pi over 5. And a negative pi over 5 is the same thing as if you were to divide 180 degrees by 5. So if you go ahead and do that, go ahead and get 36 degrees or negative 36 degrees. So past the negative 90, it's going to go negative 36 degrees. So it's going to look something like this. So it's going to look like this. It's going to go around twice, and that's going to come to here. And that is what your angle is going to look like. And then you have your reference angle here. And now we can go ahead and find that by just doing 180 degrees. Take away. And you don't want to take away like the negative 4 pi because that's just unnecessary. We can literally just take away these two. So if you add those together, you want to times this one by 5 and this one by 2. So you're going to get 5 pi plus 2 pi. So you're going to get 7 pi over 10, which is the same as here. And 7 pi over 10 is just going to be 18 times 7. So you get 126. And that is going to equal 54 degrees. So this is what your reference angle is going to be in degrees. However, if you do this in radians, which is what you need to do, this is just so you can draw it better. When you do this in radians, you're just going to go ahead and do whatever 180 is in radians. So you do pi, take away whatever these two are added together. So it's going to be 7 pi over 10. So you just times your pi by 10. So you get 10 pi over 10. So 10 take away 7 pi is going to be 3 pi. So your final answer is going to be 3 pi over 10. So this is what your reference angle is. And this is what your actual drawing should look like. Now we're going to be sketching another angle in standard position. This one you can go ahead and try this by yourself, and then I'm also going to walk through it. So you go ahead and do that, and if you get lost or if you finish it and want to know the answer, you can come back and press play. Okay, let's go ahead and start here. So first off, we're going to write our reference points for everything. You get all of these down, and then you can go ahead and start. So your reference angle is going to be, how many times does 5 go into 22? It goes in 4 times, so you get 4 pi. And then what's left over, you're going to be left with 2 pi over 5. And the reason why we get that again is because of our pi here, because this is pi over 1. If we times it by 5, we get 5 pi over 5. And then it's basically just how many times can our 5 go into this number here. Now that we have this, we know that this is less than pi over 2. So we already know that this is what our reference angle is going to be. So you can go ahead, So you can literally just go ahead here and puts equals 2 pi over 5. And the reason why you can do that is because you know that we have 2 pi, so you know that our angle is going to go around twice. And then it's going to go another 2 pi over 5. And you know that 2 pi over 5 never crosses that 90-degree line. So you know that it's in quadrant 1, so you know that that's what our reference angle is going to be. So anyways, that is what your reference angle is. And to sketch that, you just go around twice, and then you go over 2 pi, or go up 2 pi over 5. And if you want to know in degrees what 2 pi over 5 is, just so you can sketch it better, you can just divide 180 by 5, which will give you 36. And then 36 times 2, and you're going to get 72 degrees. So it will be somewhere here. And then to sketch that, you just know that it goes around twice, and then it ends up here, like so. Okay, so we're going to be converting radians to degrees. So to do this, so you get your negative 11 pi over 18. And for these, you want to have your degrees on top and your radians on bottom, because realistically, the radians are going to cancel out. But anyways, this is going to cancel out, this is going to cancel out, and it's just going to be 10. This can be canceled out and be 1. So you're going to have equals negative 11 times 10, which will equal negative 110 degrees. And that's pretty easy without a calculator. So that's your answer there. Okay, another convert question. We're converting negative 54 degrees to radians this time. So you're going to go ahead and write out your negative 54 degrees. And then you want to times it by, you want to put degrees on the bottom this time so it cancels out. So 180 on the bottom, your radians on top. And basically you just want to be able to cancel out whatever unnecessary information you have. So 54 and 180 are both divisible by 9. So you can go ahead and do this, and you're going to get 20, and this divided by 9, you get 6. Oh, you can actually divide those by 2 again. So it's actually, sorry, -6. It's actually going to be -3 and 10. So we're going to get -3 times pi over 10. So you're going to get -3 pi over 10, and that is your answer. Pretty self-explanatory, even without a calculator. The next question is determine the exact radian measure of the sector with the indicated arc length. So that is this length from here to here. And we're determining the radian measure, so we want to know what this part is. So you can see that we have our arc length and we have our radius. And we can put that our angle is equal to length over radius. And that is because basically our radian is when our radius is equal to the arc length. So if we can see how many times this radius goes into the arc length that we have described, we'll know how many radians there are. So this is going to equal 22.2 over 6. And that is going to give us 3.7, I believe. You can do long division for this, actually, if you can't do that in your head. But anyways, 22.2. So it goes into 22 3 times. Take away 18 is 4. Bring down the 2. 7 times. Yeah, so it's 3.7. Okay. So it's going to be, 3.7 radians. All right, next question is another arc length, radius, radian question. So this one's asking for arc length this time. And we have our radians, we have our radius, and it says of the indicated sector, so that is from here to here. Okay. So to find arc length for this time, radians is a percentage of the circumference. So if we times our radians by our radius, it will give us how many, or what the arc length is, and that is because radians is where the arc length is equal to the radius. So if we times it by the 5.3, then we're going to have this total circumference, I guess, that is outlined. Arc length equals radians times radius equals 5.3 times 6, which is going to give us 31.8, I believe. And don't forget to put your meters there. So that's how you get that answer. Okay, next question. Determine the exact coordinates of the point P that lies 13 units along the terminal arm of the angle 4 pi over 3. So basically what we're doing here is that each side that we'd usually have is going to be multiplied by a certain number. So in this case, our R value is multiplied to get 13. So we know that for 4 pi over 3, our reference angle is pi over 3, which is 60 degrees. And for a 60-degree triangle, we have our 60 here, and it goes across, and we would have like the square root 3, and here would be 2. However, this would be times by 6.5 to get 13. But the way to get this is you basically take this, and you get your reference angle. So you're going to get reference angle equals 60 degrees. And you're going to get the sine of 60 and the cosine of 60. Because when you're doing your graphing, you know that x equals r cos theta and y equals r sine theta. Okay. So this is going to give us the points for the reference angle. If you want to convert that to what your actual angle would be first so you don't get confused, you can do that. Okay, so first we're going to start with our reference angle. So usually for cosine of 60, we are going to get our 1 over 2. And for sine of 60, you get your square root of 3 over 2. Now, this is for our reference angle 60 degrees, but when we have our 4 pi over 3, it is in quadrant 3. And in quadrant 3, both cosine and sine are negative. So you have to go ahead and put when you do sine of your 4 pi over 3, 240 degrees, you get negative square root 3 over 2. And for cosine of 240, you get negative 1 over 2. And that's important for when you're doing this step here because it makes sure you don't forget your negatives. So let's go ahead and do it for x. So x equals r, which is 13, times cosine of 240 degrees, which is equal to 13 times 1 over 2. And that is going to give you your negative 13 over 2. So this is what your x value is going to be. And now for our y value, do y equals 13 sine of 240 equals 13 times negative square root 3 over 2. And this is going to give you negative 13 square root 3 over 2. So this is your y and x value. X is here, y is here. So for your point, you're going to get negative 13 over 2 and negative 13 square root 3 over 2. Next one is evaluating cosine of pi over 4. So basically, what does this ratio equal? This is where you kind of have to understand your radians. We have to know basically that pi is 180. So if we divide 180 by 4, we're going to get 45. That's the same thing as that you know that pi over 2 is 90, and if you divide 90 by 2, you get 45. So let's say do that. You have to put it into the ratio form. So basically, it is that our reference angle, this does not equal that, sorry. Our reference angle equals 45 degrees. And we know that cosine of 45 degrees is x over our hypotenuse. So it's going to equal 1 over square root 2, which is equal to square root 2 over 2. This is what the ratio is. And then that's just what you put this equal as. So it'd be square root 2 over 2. And that's how you evaluate it. Basically, you just find what like the ratio is. You can find what the degree equals. And you just put that as what it's equal to. Next one, we have a negative radian here. So what you want to go and do for negative radians, it's very similar to just normal radians. The only difference is that you're going to have to make sure you know what quadrant you are in. So for this one specifically, we have negative 5 pi over 6. We know that it is less than negative 180 degrees, and we know that it's more than negative 90 degrees, and that is because 5 pi over 6 is greater than pi over 2, but it is less than pi. So that means that we are going to be in quadrant 3, and that is because when we have this, if we're going the negative direction, this is negative 90, this is negative 80. If it's greater than negative 90 but less than negative 80, then we know it's in this quadrant. So you just have to make sure that you're looking out for what quadrant you're in here. So we can, now that we know that we're in quadrant 3, we can go ahead and find our reference angle. So we know that pi over 6 is 30 degrees, and we can actually times 30 degrees by 5, which is here, to get 150 degrees. So we know that this is equal to negative 150 degrees, and we can actually just do 180 take away 150, and we're going to get left with a reference angle of 30 degrees. You can also just get the reference angle by ignoring that 5 there and just doing like in the negative, obviously, and just doing pi over 6. But it's easier just to work it out this way. So anyways, our reference angle is 30 degrees, which is going to mean that our ratio is going to be, for sine, opposite over hypotenuse. So it is 1 over 2. However, we are in quadrant 3, so it's going to be a negative. So we have negative 1 over 2. So you can just put this equals negative 1 over 2. And that is your answer there. Okay, use the given information to determine exact radius of the circle. So we're looking for r here. We have radians, we have arc length, and we're using this part of the circle. So anyways, radius is going to equal arc length divided by radians. You can always remember it. You can always remember it because radians equals length over radius. And if you just times both sides by radius, divide by the angle, then you're left with this equation. And it's also because your length, 1 radian, is going to equal what the radius is for that spot. So if you divide your length by the number, or divide it by your radians, then you're left with what 1 radian equals, which is going to be what your radius equals. So anyways, it's going to equal 23.8 over 3.4, and I believe that will give you 7. It looks like it will give you 7. You can actually go ahead and test that by doing your long division. But I believe it is 7. Actually, you can just do this by testing it here. So 7 times 3.4, 7 times 3 is 21, plus 2.8, 23.8. Yeah, so that's your answer. You can do long division if you're not sure, but that one's a pretty simple one to do. Okay, I think this is the second last question. So evaluate cosine of theta equals 1 over 2. And theta is greater than or equal to 0, but less than 2 pi. So to go ahead and do this, you want to figure out what this ratio is equal to in our special triangles. So when we have cosine of 1 over 2, we know that it is going to be a 30, 60, 90 triangle because our hypotenuse here is 2. And we know specifically that it is going to be 60 degrees because adjacent to 60 is 1 and the hypotenuse is 2. So we're going to get the reference angle equals 60 degrees. Okay, now that we have the reference angle, we can go ahead and see what quadrants it can be in. We know that it's greater than or equal to 0, but less than 360. And in this case, our ratio here is positive, so we know that it's either in the first quadrant or the fourth quadrant. So in that case, we can go ahead and do, for quadrant 1, theta equals 60, and for quadrant 2, theta equals 300 degrees. And then you just want to put this into radians because our original is asking for radians. So for 60 degrees, the radians for that is pi over 3. And for 300, it is 5 pi over 3. So that should be the 2 answers that you get there. Next, we are evaluating tan of 3 pi over 2. So you're just going to be finding the ratio for this. So we can actually go ahead and start by finding out what our angle is in degrees. And you can do that by just doing 3 over 2 times pi. But for this case, we know that this is 270 degrees. So it's going to end up being tan of 270 degrees. It's going to end up being y over x, which is 1 over 0. And we can see that for this question, it is, negative 1 over 0. But for this question, it's undefined because you can never divide by 0. So it's just going to equal undefined. Okay, and that is the end of part 1. This was all just basic trig. In the next part, we're going to look at transforming sinusoidal waves, and we're going to be looking at just different ways of graphing trig functions. So that is the end of this video. If you have any questions or need help with anything, just let me know, and I don't mind helping you further. I kind of rushed through this video. Also, I'm going to be adding the shout out for this video. But that is the end of this video, and hopefully it helped and hopefully you enjoyed.